हो गया सर शायद मेरे ख्याल से। हाँ ठीक है। Yes, good afternoon students, and I welcome you again to the part 3 of Unit 2 tablets, Industrial Pharmacy First, BP502T, B Pharm 5th semester. So, let us go to the first slide, and we are going to discuss binders and adhesives here. So, what is the definition of binder? So, agents which are used to impart cohesive qualities to the powdered material are referred to as binders or granulators. So, cohesiveness, what do you mean by cohesiveness? So cohesiveness means all the materials, including the drug material and the excipients, they become cohesive and they have a tendency to come together and to form agglomerates, or they will bind together, and so they are referred as binders or granulators, because we need to granulate the whole mixture of the powder, because eventually only granules can, they are always granulated. It is always preferable to have granules for the punching of the tablet instead of the dry powder or the mixture of powder. So we always granulate it. And why we always granulate it? Because granulation will make all the drug powder into similar shape and size, which will help in the flow properties of the granules. And if the granules are spherical in nature, so they will have minimum contact area, which will help in the flow of granules through the hopper during the tableting compression machine. And objectives of the incorporation of binders: they impart a cohesiveness to the tablet formulation, both direct compression and wet granulation method, which ensures the tablet remaining intact after compression. So it should not happen that when we compress the powdered material into the tablet die punch, and when it is removed from the die punch, the tablet will come out, but eventually it will break and it will fall apart in a form of powder. So it should not happen. So that's why we use the binders. And they improve the free flowing properties by the formation of granules of desired size and hardness. So also hardness is also required of the granules, because it will help in the flow properties. So now characteristics of binder. So method 1. Binders are used in dry form in the powder and then moistened with a solvent. So always a solvent is used with the binder to form a wet lump of the drug mixture. And method 2 is binders are often added in solution form. So first one, that they can be added in dry form, and second, they can be added in the solution form. And it requires lower concentration of the binder. If we are going to add it in the solution form, so definitely we need low concentration of the binder. So by method 1, the binder is not as effective in reaching and wetting each of the particle within the mass of the powder. Each of the particle and powder blend has a coating of adsorbed air on its surface, and it is this film of air which must be penetrated before the powder can be wetted by the binder solution, right? Because all the powder mixture has one layer of air adsorbed on the surface, so this has to be displaced by the binder. Then only it can form a film on the powder mass. And method 3, in direct compression method, MCC, microcrystalline cellulose or microcrystalline dextrose, amylose and PVP are used, and these have good flow property and cohesiveness as well. It has been postulated that MCC is a special form of cellulose fibril in which individual crystallites are held together largely by hydrogen bonding, and the disintegration of tablet containing cellulose occurs by breaking intercrystalline bonds by the disintegrating medium. So when we use microcrystalline cellulose, what happens? As soon as it comes in the contact of disintegrating medium, that is our gastric medium, so it breaks this intercrystalline bond, and it is it also helps in disintegration of the tablet, where MCC is used as a binder. So what other binders and adhesives we are using in pharmaceutical formulation? So first one is the cornstarch. Cornstarch is often used in the concentration of 10 to 20%. Method of preparation: cornstarch is dispersed in cold purified water to make a 5 to 10% weight by weight suspension. Because it is not soluble in water, it is a suspension, it is dispersed in cold water, and then warming in water, both with continuous stirring until a translucent paste is formed. And actually hydrolysis of starch takes place. In this process, hydrolysis of the starch takes place. Now second one is liquid glucose, which is 50% solution in water, and it is a very common binding agent. Sucrose solution, it is used in the concentration of 50 to 74%. Sugar solution is used as binder. They produce hard but brittle granules, and their cost is low. Gelatin solution, concentration used is 10 to 20%. It is aqueous solution and should be prepared freshly and added in warm condition, otherwise it will become solid. Method of preparation: the gelatin is dispersed in cold water and allowed to stand until hydrated. The hydrated mass is warmed in water bath to dissolve. So we have to take care of the temperature of the solution. Now we talk about the cellulosic solutions. HPMC, hydroxypropyl methyl cellulose. It is soluble in cold water. Method of preparation: HPMC is dispersed in hot water under agitation. The mixture is cooled as quickly as possible and as low as possible. That means it has to be cooled down quickly and to the lowest temperature which is possible, to the lowest possible temperature. And second one is HEC, hydroxyethyl cellulose. Hydroxypropyl cellulose are other successful binders. PVP, polyvinyl pyrrolidone, used as an aqueous or alcoholic solution. Concentration is 2% and it may vary. So this is for binder and adhesive. Thank you so much.